we use AI every single day, and we totally expect it to be flawless, right? But what if I told you there's this unseen guardian working behind the scenes, making sure the AI in your favorite gadgets doesn't just work, but works perfectly? Well, that guardian has a name. It's ZAPTEST. Seriously, think about it for a second. When you ask your smart assistant a question or get a recommendation, it feels like pure magic, instant. But that magic is constantly, and I mean constantly, one tiny step away from complete failure. So what's that hidden step? What's the secret sauce that keeps it all from falling apart? That's exactly what we're going to break down. Look, we've gotten so used to our AI being lightning fast and unbelievably reliable. It's in our phones, our cars, our homes. We just depend on this seamless, always-on performance. It's not something we hope for anymore. It's something we absolutely expect. But here's the thing. To deliver that amazing experience, every single AI has a critical weak spot. A single moment where everything could just go wrong before it ever gets to you. And this all happens deep inside what you might call the AI's brain. And that brings us to this term, the inference engine. This is the absolute core of the AI. It's the part that actually thinks and makes decisions in real time. We're talking about the powerful tech from companies like Grok and NVIDIA that's the engine behind all the AI you use every day. And this right here is the high-stakes moment. When the AI is processing your request, it's the inference engine that's doing all the heavy lifting. It's where the digital magic happens, for sure, but it's also the single most vulnerable part of the entire process. So why is it so vulnerable? Well, because the real world is messy. It's unpredictable. The inference engine has to perform under huge pressure without slowing down or creating bottlenecks. And without some kind of tough checking process, it can fail. And that failure, it happens long before the result ever makes it to your screen. So how do you solve a problem like this? How can you possibly guarantee performance? Well, this is where ZAPTEST comes in. It's the assurance engine. And the concept is just so beautifully elegant. You test an AI with an even smarter AI. Yep, you heard that right. The solution to making sure our AI is tough enough for the real world is to have another AI put it through its paces. It's such a modern, powerful solution for a very complex and very modern problem. I mean, this quote from ZAPTEST's own use case really says it all. The whole mission is to use AI-driven testing to ensure inference engines perform reliably. It's that simple, and it's that absolutely critical. Okay, so how does it actually work? Well, think of ZAPTEST as the ultimate quality control inspector on a super high-speed assembly line. First, it cooks up tons of chaotic, real-world scenarios. Then, it just throws them at the AI's inference engine, really pushing it to its limits. And finally, by analyzing all those results, it makes sure that every single thought that AI has is reliable and ready for you. But let's be real, why does any of this techie stuff matter? Because this whole assurance process is what takes an AI from being some cool lab experiment to being a dependable, trustworthy tool right there in your living room. I mean, the difference is just night and day. On one side, you've got unchecked AI. It's unpredictable, it's prone to failure, and it's definitely not ready for you and me. But after ZAPTEST does its thing, you get an AI that's reliable, high-performing, and absolutely ready for the products we all depend on. So the real takeaway here is this. ZAPTEST is that invisible layer of trust. It's this silent guardian in the background that guarantees the super complex, super powerful AI inside our technology performs flawlessly every single time. It's the reason it just works. You know, all this leaves us with a really fascinating question for the future. If today's solution is AI testing AI, what comes next? As we start to rely on these systems for more and more important things, who are we going to trust to test the testers? Definitely something to think about.